the definition of a parallel circuit is a circuit that has more than one current loop. So let's look at this. As we go from the positive terminal, we see that the current goes to junction 2. So that would be the total current, but then it splits up and it goes into R1. So R1 has its own current. Some of it goes into I3, and that's the current for R2, I2. And then the third current goes into R3, I3. And when they get back to junction 7 over here, it's back to being I. So the voltage across R1 is R1, I1, and the voltage across R2 is R2, I2, and the voltage across R3 is R2, I3. But notice something. If I measure the voltage from point 1 to point 8, it's going to be the voltage of the battery. And if I come over here to this point, the voltage is going to be the voltage of the battery, 9 volts. If I measure the voltage across 2 and 7, it will be the same voltage as the battery. Across 3 and 6 will be the voltage of the battery, and across 4 and 5 will be the voltage of the battery. So V1 and V2 and V3 are all V. So resistors in series have more than one current loop, which means the total current is equal to the sum of each of the current paths. So I equals I1 plus I2 plus I3. And they all have the same voltage. So this is exactly opposite to the series circuit where they all have the same current but different voltages. So since they have the same, since all of the currents add up to be I1, I2, and I3, we can solve the equation V equals I1 R1 for I1, and that would be V divided by R1. And for R2, it would be V divided by I2 would be V divided by R2, and I3 is going to be whatever the voltage of the battery is divided by R3. So if I plug those in, you notice that we can pull out a common term, V. So V is the voltage of the battery. I is the total current, the sum of all these currents. And V times 1 over R1 plus 1 over R2 plus 1 over R3. This number here is going to be how we find the equivalent resistance. So the way we do that is actually this is going to be 1 over that, right? Because this is V divided by that. So it's really V, oh yeah, it is there. I just didn't see it. 1 over all that. So this is going to be REQ. It's going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. So for example, if all of these, if we wanted to do an example here and find the equivalent resistance, it would be 1 over 10K plus 1 over 2K plus 1 over 1K. And that's going to be 1 over REQ. So I'm going to put these in my calculator. I'm going to go, so first one is 10, 1 over, plus 2, 1 over, plus 1, 1 over, equals 1.6. So 1 over REQ equals 1.6 kilo ohms to the negative 1, to the inverse of that. And so look, how do I find the actual resistance, right? So the way I'm going to do that is I'm going to take the inverse of that number. So if I take the inverse of that, REQ equals 0.625 kilo ohms. If I take that out of scientific notation, it'd be 625 ohms. times 10 to the 3 or times 1,000 would be 625 ohms. Let's do another example. Okay. So let's say that we know that we have 12 amps of current. So this is our current, I. It's equal to 12 amps. And it's going to break up into 1, 2, 3, 4 currents. So 12 amps is equal to I1 plus I2 plus I3 plus I4. Let's figure out what all of these are. So first of all, notice that the number given here for the resistance is the wattage. So remember that if we know, actually, let's not call this the wattage. Let's change this to ohms to make it a little easier for us. Ohms. So one thing we know is that if we were to just look at this by itself, just this one resistor, that the voltage across R1 is going to be equal to the current through it times the resistance through it. But we don't know what I1 is, do we? Do we know what I1 is? No, we have no idea what I1 is. We don't know what the voltage is. So how do we do this? Well, we know this. We know what I is. So we know that I is a total current, right? We know that the voltage of the total battery is equal to the current in the total system times REQ. So let's find REQ first. REQ equals 1 over 90 plus 1 over 60 plus 1 over 30 plus 1 over 20, and then we're going to take the inverse of that. So 90, 1 over plus 60, 1 over plus 30, 1 over plus 20, 1 over equals, and then take 1 over that. And so REQ is 9.0 ohms. So if I want to know what the voltage is of the battery, it's going to be 12 amps times REQ, or 9.0 ohms, which is 108 volts. 108 volts. So let's make a little chart here to make it easier for us. We're going to R1, R2, R3, R4. I'm going to put I here, and we're going to put V here. So I is the same as 12 amps for all of these. Right? And we're going to put R here, and R is 90 ohms, 60 ohms, 30 ohms, and 20 ohms. And we want to know the, actually I just screwed this up. That is not the current for that. I totally screwed that up. I am sorry. So what I did wrong is I said that these all had the same current. They don't, right? The total current is a sum of each of the currents in each one of them. You find those currents by taking the voltage, which is the same for each of them. It's equal to that of the battery, which we just found over here. All of these have a voltage of 108. So if we want to know the current in the 90, it's going to be 108 divided by 90, which is 1.2. And for 108 divided by 60 is 1.8. So this is 1.2 amps, 1.8 amps. And 108 divided by 30 is 3.6. Notice that half the resistance has twice the current. That makes sense. And a third of the resistance is going to have 3 times the current. Let's just double check that. So this will be 108 divided by 20, which is 5.4. Now, if we add all of these together, they should add up to 12 amps. So this is 2 plus 8, which is a 10, and 6 plus 4, which is another 10. So this is 20. 2, 4, 3, 4, 6, 7, 8, and 12. Here we go. We got it. Now, we'll turn our attention and do a circuit in the next video that has everything in it.